This video is looking at applications of quadratic functions or quadratic equations. So here's our first example. The path of an Acapulco cliff diver as he dives into the sea is given by this equation. H equals negative t squared plus 2t plus 24, where h is the height of the diver in meters and t is the time in seconds after he dives. So the first thing we're going to do is we're going to look at all of the different forms and pull out the important information. So question A asks us to factor to write it in x-intercept form, right? This equation is given in standard form. First, we're going to get x-intercept form, and then we're going to use graphing technology to help us get vertex form. So go ahead and try to factor that into x-intercept form. Okay, check out how you did. So first I pulled out the -1 common factor. I divided every piece by -1. And then I just found two numbers that multiply to -24. So I went with 6 and 4. And I needed it to be -6 plus 4 to get me to -2t. So now if I punch this equation into Desmos, so that's what I would like you to do, and you can put in the standard form. You're going to want to probably use y's and x's. We'll talk about what the h and the t mean in terms of the scenario in a minute. You can punch in either the standard form or the factored form. Okay, and I want you to go to that graph, and I want you to take a look at it and see if you can come up with the vertex. Okay, so hopefully you can see from the graph just by clicking on the vertex that it has a vertex of 1, 25. Okay, and we already know the a value, right? We already know that a is -1 or 1 if you like, and it opens down. So it's the same stretch factor regardless of what form we're in. So the equation in vertex form then is y equals -1 if you like, x minus 1 squared plus 25. Okay, so using all of this information, I'd like us to put it together on our sketch of the parabola here just so we can see all of the key points. Okay, so key points. We just found out that this vertex is 125. We know that this x-intercept is 6, right? This one comes from this bracket, this binomial right there. So this point is 6, 0, and this point right here is -4, 0 coming from this one right here, right? Here we get x equals 6. Here we get x equals -4. And we also know the y-intercept from the original question. And we can see that from standard form, it's 24, so obviously our graph is not really to scale here, but this is just a general shape of a parabola so that you can get the idea of the key points there. That's our y-intercept. And if you like, it can be written as 0, 24, right? Okay, so now we do the key interpreting of the scenario. Okay, so let's just go back to our original. We know that x was actually t in this case. That stood for time in seconds, and I'm just going to write that in to help us remember that. And we know that our y was h, which was height in meters, right? So the next question is, how high up the cliff was the diver when he started his jump? Okay, so when did he start his jump? He started his jump right here, right? And then he jumped up and went down. Okay, so to start, that's actually me asking you about the y-intercept, right? That's really what I'm asking you for here. And so he was 24 meters at the start of his jump at time equals 0, right? This is time equals 0. Okay, when did the diver land into the sea? So hopefully you can see that this is when he landed. That's when his height is 0. Okay, so he landed when? At 6 seconds. So that's one of the x-intercepts, right? The other x-intercept doesn't actually make sense in this scenario, note. So really this part of the graph right here is not applicable in real life, right? So we're using this model to model a real life scenario, but when t is negative, when time is negative, that doesn't really make sense. Okay, next two questions go together. When did the diver reach his maximum height? And what was the maximum height of the diver? So this is me asking you about the vertex. Okay, when did he reach it? That is when x equals 1. Okay, so at 1 second is when he reached the maximum height. what is the maximum height? The max height is 25 meters. Okay, units being really, really important here when you're answering questions like this. Okay, so you're going to try another one of these and see if you can get this idea. It's just interpreting the different forms of the quadratic equation or function. Okay, so we're going to try one more that sort of has different meanings, but the same concept, looking at the equation and what everything means. The Quadratics Cup is a new coffee shop that sells various coffee-related items. The profit of this new shop can be described by this equation. P equals negative 4n squared plus 64n minus 112, where P represents the profit in thousands of dollars and n represents the number of customers in 10,000s. Okay, so those meanings will come to be important when we start answering questions. First step, you're going to factor to write it in x-intercept form. I want you to use graphing technology to come up with vertex form, and I want you to use all three forms to try to label the graph with all the key points just like we did. So that part remains the same. I'd like you to pause the video and try to do as much of that as you can on your own. Okay, so check it out. How'd you do? Here's where I got to my x-intercept form, also just stating what the x-intercepts are. I got the vertex 8144 from Graphing Technology to write the equation in vertex form, and then you can see I've labeled all of the necessary points on this graph. Okay, so let's go ahead and see if we can interpret some of this. Okay, first question, what is the profit if no customers visit the store? No customers that visit the store, the profit is negative 112, okay? And here's where those units become important. It's actually the profit in thousands of dollars, and so it's actually negative 112,000, right? Dollars. They're in the hole if no customers come to the store. Okay, the next question, determine the break-even points of the store, i.e. no profit. Remember that this right here, zero profit, right? So here's where you make zero profit. So this is break-even points are really the x-intercepts, right? So we see that it's when n is 2, the number of customers is 2 and 14, but don't forget, go back to the original question, n is number of customers in 10,000. When n equals 2 and n equals 14. So in 10,000s, that's 2 10,000s, which is 20,000, or 14 10,000s, which is actually 140,000 customers, right? So they will break even if they have 20,000 customers or 140,000 customers. Okay, the maximum possible profit of the store. Okay, maximum, hopefully that makes sense to you that we are looking here at the vertex when we talk about that. Okay, so what is the most profit they can make? This is the y value here, right? It occurs when we're at n equals 8, but I'm actually asking you for the profit here, so it's 144. But don't forget that that's in thousands, so the maximum profit that they can make is $144,000, right? So we're going to practice some of these applications, and hopefully you can interpret the information.